So go ahead and do 1 through 6 warm up. Push pause, try them, and then push play to check your answers when you're ready. Number 1, obtuse. Number 2, setting those sides opposite those congruent angles equal and solving and getting y is 12. Number 3, equilateral means all the sides are equal, so you can pick any 2 and set them equal, but we don't do all 3. We just pick 2 of the sides and set them equal since all 3 sides are equal. And get x is 9. And then naming the right triangles, triangle ADB and triangle ADC. And then classifying if they're all different, it's scaling. And then this one, which one's not a classification? Well, they're all acute. They all have at least 2 sides congruent and they're all equal angles. So it's not scaling because that would be different sides and they are all the same. So in this lesson, what we're going to look at is finding some interior and exterior angles. One thing to kind of see here is this is called an auxiliary line, and it can just help if you put that line in there to kind of see different angles and help you. So just wanted you to know what that line was called. So the first thing we're going to do is kind of this triangle sum project. So in the back of your packet, you have 3 different triangles, and you're going to take out triangle 1, mark off kind of some of those angles kind of in a wavy part, make sure they're big enough, not teeny. And then you're going to kind of decorate. You don't have to get too fancy with it. This is a quick thing. And then you're going to cut out those 3 triangles and arrange it so that they are adjacent to each other. So it's going to kind of look like polka dots there, purple. There's the purple one all colored in. And then here is my striped one. And notice that they form a line. So triangle sum theorem means that all 3 angles add up. All 3 angles in the triangle add to 180 because they form a line. They all add up to 180. So let's practice that. Here's a triangle right here, 43, 74, and 1. We don't know what 1 is, but we can find it by taking 180 minus 43 and minus 74 to figure out what would be left. And you would get 63. Angle 2 and 1 are vertical, so that would mean angle 2 would have to be 63 as well. And now that you know this one's 63, you can figure out what angle 3 is because all 3 of these have to add up to 180. So go ahead and pause and try that. And you should have gotten 38. When you take 180 minus 79 minus 63, the 2 angles you do know. So some more practice with that. Let's go ahead and find angle 1. Well, this forms a linear pair when they're next to each other. So 180 minus 57, and that's 123. And now that we know it, I like to kind of put it in there to help me find. Now I can find angle 3 by taking 180 minus 123 and minus the 28. And that's going to give me 29. And then go ahead and figure out what angle 2 is by subtracting the 2 that you know in that triangle from 180 to help you figure out angle 2. And you should have gotten 52. So working our way around this triangle, always look for the one pair of where you've got 2 angles and then you can find the third. So 180 minus 58 minus 65 is going to give you 57. So we know angle 7 is 57 degrees. And then we can work our way around. We know that this is a linear pair with 6. So 180 minus 57 is going to give me the measure of angle 6. And that's 123. And once I know it, I'm going to put it in. And look at that. These are congruent. So that means I'm going to take 180 minus that vertex angle, 123, and that's going to give me the total of both of those together. And since they're the same, I can go ahead and divide what's left, 57, by 2 to get 8 and 9. So 57 divided by 2 is 28.5 degrees. Don't forget your degrees in there. And then for 4 and 5, so 5 is going to have to be 57 because it's either vertical or it's a linear pair with the 123, however you want to look at that. So 57, and once we know that's 57, we have 2 of the 3, so 180 minus 57 minus 67, whoops, 67, to get angle 4. And that gives me 56. So for our next project, we're going to go back to those triangles at the back, and we're going to look at triangle 2. Mark off the angles opposite, not next to, so not the one forming the linear pair with it, but the other two kind of farther away from that exterior angle. And we're going to decorate those, and then we're going to cut those out, and then we're going to place them here. So we're not cutting triangle 3, we're going to place those two angles that we cut out onto that triangle 3. And notice that that exterior angle is adding up the two remote, as we call them, remote interior angles, the one not adjacent to. So 2 angles across, add to equal exterior, however you want to write that angle. So exterior angle here is 4. The remote interior would be 1 and 3. It's not 2, it's not the one that's next to it, it's the other 2 that are further away. So 1 plus 3 is going to equal angle 4. So let's see here. B and A are going to add to equal my exterior angle. So x plus 65 equals 2x plus 10. And then we solve. And subtract 10. So x equals 55, and then it asks for ACD. And I know ACD is this angle here, the 2x plus 10, my exterior angle. So I'm going to take 2 times 55 plus 10, and that is going to be 120 degrees for my exterior angle. So go ahead and try this one. Add up your 2 remote interior and set it equal to your exterior. And double check your answer that you got 80 for X and you got 112 for angle FLW, which is your exterior angle. All right, a corollary is just a theorem that can be proven directly from another theorem. And so we actually kind of know these because in acute angles, those acute angles in a right triangle, those would have to be complementary because they would have to add up to 90, since we know the total in a triangle is 180, and if one of them is 90, that leaves the other 2 having to add up to 90, which makes them complementary. And then there can only be at most one right or obtuse angle in a triangle because, again, your sum is 180, and if you take and use one obtuse, there's no way to have another obtuse. And again, 90, you can only have one that's 90 because if you made another one 90, that's only 2 angles, and a triangle has 3. And angles in equiangular triangle, if they're all equal, we know 180 divided by 3 equally, they all have to be 60 degrees.